one interesting aspect people usually ask is, with all these little creatures, is this system more sensitive? You know, what happens if some bad guy dumps some really nasty stuff into the sewer? You know, are your snails going to be all right, or your little fish and your frogs and all of that? And the experience is clearly, unequivocally, that these systems are more stable than the traditional systems. And the explanation is relatively simple, actually. Because if we think about, on a global level, that we are very concerned about losing species in various ecosystems. And the reason we are concerned about that, because all those species form an important building block of that particular ecosystem. And once we lose the building blocks, you know, the stability of those systems will be reduced. And enough building blocks removed, you get a very fragile system, if not a complete collapse. What we are saying is the industry, the wastewater treatment industry, has been using a limited ecosystem for 100 years of a few hundred species. Let's just reverse the thinking, increase the diversity, and we'll get stability. And that's exactly what we have been experiencing. Naturally, every biological system can be wiped out with sufficient resolve. But what we are finding, you need more poison, more nasty stuff to make a nasty impact on an organic ecosystem or a complex ecosystem than on a simpler one. So on this picture, what you see is in the operational data of a treatment plant that runs over a year, and the upper line is the changes in the influent qualities, you know, how dirty the water is, and at the bottom you see in the green one what is the outgoing quality. That means that even with very wide fluctuations of the quality of the water that comes in, you get a very stable treatment. So that was one point. We talked about our ability to keep more species as well as many more bugs or creatures in the same reactor space. That, at the end of the day, that translates to a savings in footprint, which then means you need to build less concrete, less tanks, you need less land, and that actually means that the organic treatment plants end up being lower in investment cost, and that's really the reason. Then the competition. And what you see here is other ubiquitous technologies out there, such as activated sludge, and we measure everything compared to activated sludge because all the built treatment plants around the world, 98% of all treatment plants are actually using activated sludge technology. It's changing slowly, but it's still there. And the other technology that we make the comparison here is MBR, SBR, and MBBR, which stand for membrane bioreactor, moving bed bioreactor, and sequence batch reactors. Let's just take a look at the other one. When it comes to operational costs, there are two aspects that really determine the cost of running a treatment plant. One is how much energy you use, and the other one is how much sludge you produce, because you have to do something with that sludge. You can't just swim there. You need to take it away. You need to de-water it, because in its original form it looks like black coffee. It's like 1 or 2% of dry matter content. So one, because the energy use is about 30%, 35% depending on the size, is lower. And second, because in these systems we produce less sludge, because we are fueling a much more complex ecosystem with the available food. These two elements translate to the fact that we have a significant operational advantage, which is depending on size, water temperature, location, but it's somewhere between 30–40%. We talked about the energy efficiency, wrapped up all in the operational expenses as well as the sludge production differences. This is pretty much a slide that summarizes the various technologies. What you can see that compared to the good old activated sludge, various technologies would have advantages in different aspects, such as let's say in opex, let's say MBBR would have a little bit better in one aspect, or footprint, or operational, or capital expenses. What we can say about the Organica, that in all aspects it outperforms the other options. Another interesting aspect that we find is that with the complex ecosystems, you have obviously much more diversity, and you have a better appetite for unusual food. Unusual food now would mean xenobiotics, persistent organic compounds, more complex chemicals. And we find what you see here is the most widely used painkillers, for example, in Europe. Those of you who don't recognize the names, feel lucky because you haven't been exposed to much painkillers. But the point is, what we find is on the left-hand side with the grayscale, you see how much traditional treatment plant will remove of these materials. And with the green one, you see how much more a complex ecology removes all of these. And generally, worldwide, there's a tendency now to start to address the removal of these kind of hormones and pharmaceuticals out of the wastewater, because it's very soon makes its way into our drinking water supply. And what we find is that Organica plants are actually producing, in that sense, much cleaner water.